Let's examine VideoIQ's appearance search. So what appearance search will allow you to do is you can click on certain objects that VideoIQ detects, and then you can search for other objects that look similarly to those objects. There's two main points that I'd want to leave this to you in this presentation is one, if you choose relatively large and relatively distinct objects, kind of like a bus like we have here, the system will do a good job, especially on the same camera in the same lighting conditions, to return a match. What's more difficult in the variety of tests that we did over multiple months is if you're trying to basically get objects, like if you have a person who's very large, or for instance, this person is very small in this scene that we grabbed him from this image. If you try to find this person on a field of view that's 30 feet wide, it's going to be much more difficult. The other challenge, of course, is if this is only searching over one camera, but if you're searching over dozens of cameras, you can imagine that basically sorting through all of this, at a certain point, it may be conceptually better than searching through the native video itself. It still may feel like searching for a needle in a haystack. Let me start by showing you what the basic process is. So you'll do just a normal search, and you can search for people or vehicles, whatever you might want to search for. Then what you can do is you can click on the object or the bounding box, and that will grab that object to do for an appearance search. So this is, for instance, what I did. I clicked on this individual a few moments ago, and I grabbed him, and it automatically went up there. You can do the same thing, for instance, with vehicles, and that's how I clicked. And you'll see here I just clicked on this this minivan, and now the minivan is displayed in the list of choices. So that's how you start. You can't like draw over an object if the object isn't tagged. You can't sort of change sort of the object size. It's based on clicking on what's available in the video playback. So let me start by using the trolley. So I'm going to add the trolley in, and I'm going to search for the trolley in 2 hours during the day. I've done these types of searches before. First of all, the same lighting conditions helps a lot. I've done other searches, and let me start the search for you. If you search basically over like different camera positions, where this might only see this object in a much smaller, or basically only a partial, or basically the coloration has been changed by shadows, etc., you will see differences and certainly drop off in performance. But I'm just doing over a 2-hour period to show you the basics, and the technology definitely works on the small scale. So you can see here that we search for this very large, distinct object, this trolley. These trolleys come through this neighborhood very constantly, and you can see one after the other, it's found trolleys in every single match in the first page. You'll also see that these are scores: 31%, 25%, 23%. These are the probabilities that it is a match. I'll go down towards the middle to show you some other results. And maybe with this trolley, we'll see basically how these results look here. So you can see as you get lower down, sort of you get less matches, which is fine if you're doing over a 2-hour period distinct object. But again, over a larger scale time frame, that's what you need to be more concerned of doing those types of searches. So in general, certainly, fundamentally, the technology worked at small scale. What we found in a variety of tests is that if you change lighting, object size, camera positioning, or larger time frames, for instance, a person changing clothes, right? And we'll never get someone changing clothes. It may very weakly sort of match in our test that we did, but those are all things that are going to be key considerations if you try to use this at a large scale.